Welcome back to RamZland. Today I want to talk to you a little bit about mass, convection, and momentum. Check it out.
All you need for this lab is a candle. You're going to need a lighter and a couple glasses, and you're going to need a needle to press right through the center of your candle. The essential question in this lab is, what makes the candle move? So as you light both sides of the candle, ask yourself, what makes the candle move? Some people think it's the lack of mass. As wax drips off each end of the candle, the fulcrum favors the side of the candle that weighs less to point upward. Other people think that this is really a demonstration of convection through a gas. Hot air rising influences the movement of the candle. Still others think it's an issue of momentum. As one side of the candle loses mass, it causes the other side to dip downward, and that causes momentum. And that motion of the candle moving back and forth is an example of objects in motion want to stay in motion. That's one of our Newtonian laws. Ask yourself, what do you think is the primary reason that candle moves? And the longer it stays lit, the more it wants to move. Now the key in this is make sure that you've got that needle going right through the center of the candle. Make sure that you start out by lighting both ends of the candle at the same time. And you want it to be as balanced as possible. And it's sort of like a teeter-totter. What makes that candle move? Is it momentum? Is it convection? Is it a loss of mass? Maybe it's a little bit of all three. Convection, momentum, and mass in RamZland.
So remember that momentum equals mass times velocity. So an object of really any mass, if it's not moving, it has a momentum that equals 0 because its velocity equals 0. I hope you enjoyed today's edition of RamZland, and I'll see you next time.